Hi everyone. In this video, I want to take you back to where exploratory spatial data analysis really began with some of our classics. So before we had interactive maps, the LISA clustering diagrams or packages in our statistical programs, there were some very foundational papers that defined what's made spatial data special and why it's challenging to analyze. So let's start with what's so special about spatial data. Um, So here, Anselm lays out the big idea that spatial data can't be treated like other kinds of data because nearby observations are related. I keep mentioning this because it's just so important for spatial analysis, and is why we can't just use normal econometric techniques. So in this paper, he introduces two key concepts: spatial dependence, what happens when one place tends to affect nearby places, and spatial heterogeneity, relationships that differ across regions. So Anselm argues that ignoring these two properties breaks the basic assumptions of most econometric models, especially the independence and the constant variance. But the real insight he had here is almost more philosophical. So he draws a line between your sort of data-driven analysis and the model-driven analysis. So the data-driven analysis is about looking at the data first, using the data to reveal the structure, the patterns, or any surprises before jumping into equations. Now, let's move on to spatial statistical analysis and GIS. This paper was written right as geographic information systems were becoming mainstream. So GIS was great at mapping and at storing data, but it didn't have a lot of analytical uses at the time. So Anselm and Wrigley argued that GIS needed to be linked with spatial statistical models if it was going to be more than just digital cartography. Drawing maps are great. A lot of questions that you want to answer in like a research paper using these tools will have a map front and center. It'll be very important. But they come up with a way to go beyond that. So if you followed a lot of the differences for staggered adoption literature over the past few years, you can see why it's important to fully understand the methods that you're working with, and especially their shortcomings. So then that's sort of what they did here, was looking at the shortcomings and going back, I guess, starting from the basics. So they frame spatial data as a realization of a spatial stochastic process. So in other words, we observe one possible pattern being generated by underlying spatial relationships. And it was this framing that let spatial data analysis borrow the rigor of econometrics and the intuition of geography. So now I'll end this lecture with exploratory spatial data analysis, linking SpaceStat and ArcView. So this shows how those ideas that we've been talking about became reality. So this is the first paper where ESDA was implemented in software. So SpaceStat, which Anselm developed, was one of the earliest programs to compute Moran's I, the LISA, and spatial regression diagnostics. By linking with ArcView, a mapping platform, users could visualize and interact with the results, so explore spatial relationships dynamically. This is the sort of thing we may take for granted today. So these papers still matter despite all the advancements that we've seen since, because they show how the logic of spatial analysis evolved. Without this work, the readings for this week wouldn't have been possible. Think of these papers as the moment when spatial thinking became computational. And they mark the transition from mapping where things are to understanding why they're there.